Alright, so today we're going to do some math problems, so if that's not what you're looking for, check out my video tomorrow. But today we're going to do math problems, and they're going to be the use of exponential notation and the metric system. So to get started, basically these are just some reasonably simple word problems, which, word problems are complicated just in general, but the main purpose of this assignment is to learn how to use exponential notation and metric system. So exponential notation is like 10 would be written as 1 times 10 to the first would be the exponential notation of that. So basically we want to use this exponential notation instead of just regular numbers. So that's what they want when we're talking about exponential notation. And then with the metric system, what they're going to do is they're going to want you to know all of this stuff. And I think they're going to give you this table on any homework or test. But basically, what it is just it's these prequel kind of things, these things in front of the numbers, and they signify things like a megaton. You might have heard of megatons of TNT. That's just we have 1,000 there, we have 1,000,000 there. So basically what it is it's just 1,000,000 tons for a megaton. So anything like ton or inch or meter, that's going to be here. It's just times 10 to the 0. It's just 1 meter, 1 ton. And then, if you have a megaton, that means 1,000,000 tons. Okay, so that's 10 to the 6th. 1 ton would be 1 times 10 to the 0. So basically, a megaton is 10 to the 6th tons. Because basically what you do is you do 10 to the 6th minus 10 to the 0, and you have, you do 6 minus 0, and you have 10 to the 6th. So if we wanted to do megatons to decitons, it would be 6 minus -1. So 6 minus -1. Those negatives create a plus. So if we wanted to convert 6 megatons into decitons, it would be 6 plus 1, so that's 7. So it would be 6 times 10 to the 7th, which we got from right there. 6 times 10 to the 7th decitons would be 6 megatons. Okay, and that would be 6 times 10 to the 6th tons. Since a ton is here, which is 10 to the 0, so that would be 6 minus 0, so that's 10 to the 6th tons. It's 10 to the 7th decitons. It would be 10 to the 8th centitons, etc. So let me reset the focus 1 second. Alright, so we're back. Okay, so that's basically the main purpose of this assignment is to those two things. Scientific notation, or exponential notation, so writing numbers like this instead of like this. A number like that would instead be like this, or it would be 1 times 10 to the 9th in exponential notation. So exponential notation and metric system. Metric system is just converting between these type of things, which I just showed you how to do. Alright, so let's jump into the problems. This first problem, it says that the USA emits 7 gigatons of CO2 per year. How many kilograms is this per citizen? And there's 350 million people, and 1 metric ton equals 10 to the 3rd kilograms. Use exponential notation. Okay, so we know that we're using tons, right? Tons, gigatons. And what we can do is we can convert that into normal tons here. And then we know that a ton is equal to 10 to the 3rd kilograms. So we want to know how many kilograms per citizen. Okay. So what we're going to want to do is get this gigaton number into kilograms, and then we're going to want to divide that by 350 million, like how many citizens there are. So it can be like there's going to be 5 kilograms per citizen, and a per is a divider. So what we can do here is let's start by converting this 7 gigatons into kilograms. So first we're going to convert it to tons. So 7 gigatons, if we look at our chart up here, giga is 10 to the 9th. So we have 7. We can do this slowly if we want. We can do gigatons. And then we can multiply that by giga, which is 10 to the 9th. Actually, that's going to be on the top. 10 to the 9th. So gigatons, this is tons, 10 to the 9th tons per 1 gigaton. So we have 7 gigatons, and we want to get rid of the gigatons and replace it with tons. And there's 10 to the 9th tons here per gigaton. You know, because a ton is just a normal 1 number, which is 10 to the 0. So, so here is the gigaton number, which is 10 to the 9th of the base unit, and the base unit is tons. So 10 to the 9th tons in 1 gigaton. So now we can get rid of the gigatons, and we just do equals 7 times 10 to the 9th tons is what we have. Alright, so now we have tons. Now we're going to need kilograms. So 1 ton is 10 to the 3 kilograms. So what we can do here is we can do 7 times 10 to the 9th tons, and we know that there's 10 to the 3rd kilograms per ton, so we want to get rid of tons, so let's put tons on the bottom. And in each ton, there's 10 to the 3rd kilograms. So we can cross the tons out, and we have 7 times 10 to the 9th times 10 to the 3rd. Now, do you know what we do when we have... What we do is we add those exponents when we're multiplying them. So it'll be 7 times 10 to the 9 plus 3, which is 10 to the 12th. And this is kilograms. So now we know we had 7 gigatons of CO2 per year. Now we converted that gigatons into kilograms of CO2 per year. Now we want how many kilograms is this per citizen. Okay, so now we have kilograms. And now we're going to want kilograms, eventually we're going to want kilograms per citizen. So how do we get kilograms per citizen? We simply multiply this, so we'll do 7 times 10 to the 12th kilograms times how many kilograms per citizen. So all we really have to do is divide, so we have a kilogram per citizen, so what that means is we just divide this number by the number of citizens, and the number of citizens was 350 million. So million is 10 to the 6th. You don't necessarily have to know that, but that will just help with what we're doing here. So that's 350 times 10 to the 6th. You could have just written out 350, comma 000, comma 000, but this is the same thing. Because this is just saying there's 6 more zeros on the end of that. Okay, so this is our kilograms here, and this is our citizen. So now all we do is we just divide these two numbers, and we'll have kilograms per citizen. So what we can do here is, I don't know, let's just use a calculator for that. So what that ends up being, when you use a calculator, I mean, you could do this by hand, but it gets a little complicated, I guess. So that ends up being, you'll get, if you type this in a calculator or whatnot, you'll get 20,000 tons per citizen. Alright, now they always say use exponential notation only. So what we're going to want to do is convert this to exponential notation. So that's just 2, and you count how many zeros. 1, 2, 3, 4. So it would be 2 times 10 to the 4th tons per citizen. And that is your answer right there. Because they wanted how many, kilograms. This is kilograms, not tons. I wrote that wrong here. This should be kilograms. This should be kilograms. Because, yeah, we had kilograms here. I just mislabeled it. Alright, so that's our kilograms per citizen. That's what they were looking for. How many kilograms is this per citizen? So, yeah, that's pretty much it there. So, yeah, that's our answer. Alright, there's something else I wanted to say, but I'm just blanking on it. So, anyway, let's move on to the next problem. That was 1A. This one is 1B. And the problem says the world's total CO2 emissions are roughly 30,000 megatons, okay? What percent of the world's CO2 is produced in the USA? Well, if we look back at this problem we just did, we had the USA emit 7 gigatons of CO2 per year. 7 gigatons, right? So let's write that down. So the USA has 7 gigatons. And now it's saying that the world has 30,000 megatons. Okay, so world, 30,000 megaton. Alright, so now, okay, we have gigatons here, we have megatons here. So let's get these into the same units. I mean, let's get this into gigatons so we can compare it with that. So 30,000 megatons, so mega here is 10 to the 6, which is million. And USA has gigatons, so gigatons is here, 10 to the 9th. So that means that 1 gigaton is 10 to the 3 bigger than 1 megaton, which is also 1,000. So 10 to the 3 is 3 extra zeros. So 3 zeros onto 1 is 1,000, right? So, we have 10 to the 3rd difference, so that means that there's 3 zeros different. That means a megaton has 3 less, it's 3 zeros less than a gigaton. So, if we want to get to gigatons, we have to divide off by 3 of these zeros. So it would be 30 gigatons. So what we can do, we can do this, the way here. So we got 30,000 megatons, and we want to get rid of megatons. And we know that a gigaton is or we can write this. There's 10 to the 3rd megatons in 1 gigaton, because we want 1 to be on the top. So there's 10 to the 3rd megatons in 1 gigaton, right? Yeah, 10 to the 3rd. Yeah, because you subtract. How many megatons can fit in a gigaton? 10 to the 3rd, because, 10 to the 3rd, because you do 9 minus 6, and that's 3. So 10 to the 3rd megatons fit into a gigaton. So 10 to the 3rd megatons in each gigaton. So that means that we can now cancel our megatons out. So we have 30,000 gigatons divided by 10 to the 3rd. Alright, so 10 to the 3rd is just 3 zeros, right? So if we're dividing by 10 to the 3rd, we can just pull 3 zeros off, and we have 30 gigatons. So the world CO2 production is 30 gigatons, which we just found here. Now, what percent of the world's CO2 is produced by the USA? So we know that 7 gigatons is from the USA. The world is 30 gigatons. So what percentage is the USA of the world? Well, to do that, we do just simply 7 divided by 30. You know, if if we're doing 30 divided by 30, that would give 1, right? 30 divided by 30 is 1. That would be, you multiply that by 100 to get the percent, that would be 100%. But the USA is only 7/30ths of the total. So we do 7 divided by 30, which ends up giving us 23.3. So it'll give us 0.233. Now, we want that to be in exponential form, or we want this to be in a percent. So a percent we multiply by 100, and we get 23%. Now, since we were using a number with one significant figure here, we should only have one significant figure here as well, and that would be 20%. Because we want to do significant figures as well, probably. So 20% is our answer. All right, next problem. All right, this says the USA has about 100 million vehicles on the road. Each car emits, on average, 9 grams of CO2 per mile driven, and is driven 1.2 times 10 to the 4th miles per year. How many kilograms of carbon monoxide does the average car emit per year? How many kilograms per year? So this is saying, does the average car emit? So when we're talking about one, this is an average car. This is a single car. So, okay, so we know that. Now, and they talk about how much each car emits. So each car emits 9 grams. So it's like, do we really need this 100 million number? It's like, if they want to know how much total, or if they gave us the total amount of CO2 that all 100 million cars gave off, then we would need this 100 million number. But really what they give us is they're saying each car emits 9 grams of CO2 per mile, and each car is driven this many miles per year. None of that is like the total amount. So we don't really need this total here. We can just do individual car, individual mileage, individual amount of carbon monoxide per year. Alright, so we want kilograms carbon monoxide per year, per car. Okay, so we know that each car emits 9 grams of carbon monoxide per mile driven, and is driven this many miles per year. So let's draw this. So we have 9 grams per mile. Right? Each car is 9 grams per mile of carbon monoxide, and each car is driven this many miles per year. So we also have 1.2 times 10 to the 4th miles per year.